Just a few decades ago, the idea of humans setting foot on Mars was pure science fiction. Today, it's not just a dream, it's an inevitability. The Red Planet has captivated scientists, explorers, and dreamers for generations. But in 2025, we stand on the brink of answering the ultimate question. Is Mars habitable? The truth is both thrilling and terrifying. Mars is a frozen desert, a world of extremes. Temperatures can plummet to a bone-chilling minus 195 degrees Fahrenheit, minus 125 degrees Celsius at the poles, while dust storms rage with enough fury to engulf the entire planet. The atmosphere is so thin, it's practically a vacuum, offering no protection from deadly cosmic radiation. And yet, we've found water. Yes, a liquid water, hidden beneath the Martian surface, in vast underground lakes, and even in the polar ice caps. Water means life, or at least the potential for it. And where there's water, humans can survive. But that's just the beginning. In 2025, NASA, SpaceX, and international space agencies are closer than ever to making Mars colonization a reality. SpaceX's Starship, designed to carry 100 passengers at a time, is undergoing final tests. NASA's Artemis missions are laying the groundwork for deep space travel, and the European Space Agency is mapping out sustainable habitats. But here's the shocking part. Mars is trying to kill us. The planet's lack of a magnetic field means solar radiation bombards its surface, increasing cancer risks for future settlers. The soil is laced with toxic perchlorates, making agriculture a nightmare without heavy filtration. And the low gravity, just 38% of Earth's, could cause muscle atrophy, bone loss, and even vision problems over time. So can we really live there? The answer is yes, but it won't be easy. Scientists are already developing revolutionary solutions. Underground cities, shielded from radiation, genetically modified crops that thrive in Martian soil, and artificial magnetic fields to protect future colonies. Elon Musk has even proposed nuking the poles to release CO2 and thicken the atmosphere, a controversial but bold plan to terraform Mars. And then there's the most mind-blowing discovery of all: signs of past or even present life. The Perseverance rover has detected organic molecules in Martian rocks, hinting at ancient microbial life. Methane's spikes in the atmosphere suggest something, possibly biological, is still active beneath the surface. If we find definitive proof of life on Mars, it will rewrite human history. But the clock is ticking. With climate change accelerating on Earth, Mars isn't just an adventure, it's a backup plan, a What's Planet B? And in 2025, we're closer than ever to making it a reality. So, is Mars habitable? Not yet, but soon. And when that day comes, humanity will no longer be a single-planet species. We will have taken our first steps toward becoming interstellar. The question isn't if we'll live on Mars, it's when. And the countdown has already begun. What do you think? Would you dare to be among the first settlers on Mars? Let us know in the comments. And stay tuned, because the next big breakthrough could happen any day now. The clock is ticking, and Mars is calling. Every new mission, every rover, every satellite we send unveils another piece of the puzzle, another clue that could determine whether humanity's future lies among the rust-colored dunes of this alien world. In 2025, we're not just asking if Mars is habitable. We're asking how soon we can make it happen. The latest images from the Mars Reconnaissance Orbiter reveals something astonishing. Seasonal liquid water flows, dark streaks called recurring slope lineal, appear and vanish with the Martian seasons, suggesting briny water might still be seeping to the surface. If confirmed, this isn't just a scientific curiosity, it's a potential lifeline for human settlers. But water alone isn't enough. The real game changer: Mars' underground lava tubes. These massive, cave-like structures, some wider than subway tunnels, could shield humans from radiation and violent dust storms. NASA's Moon-to-Mars Planetary Autonomous Construction Technologies (MIMPACT) program is already testing robots that could 3D print habitats inside these natural shelters. Imagine entire cities hidden beneath the Martian surface, a sci-fi vision rapidly becoming science fact. Then there's the air, or rather, the lack of it. Mars's atmosphere is 96% carbon dioxide, with less than 1% the pressure of Earth's. Breathing without a spacesuit is impossible. For now. But Moxie, an experiment aboard Perseverance, has already succeeded in converting CO2 into oxygen at a small scale. If scaled up, this technology could one day fill domed settlements with breathable air and even produce rocket fuel for return trips to Earth. But the most shocking revelation? Mars might still be geologically alive. Seismic data from NASA's InSight lander detected Marsquakes, hinting at a molten core. If true, this means Mars could, in theory, regenerate a magnetic field, the key to long-term survival. Scientists are even exploring artificial methods, like placing a massive magnetic shield at Mars' Lagrange point to deflect solar radiation and help rebuild the atmosphere over centuries. Yet the biggest obstacle isn't technology, it's us. Human physiology wasn't built for Mars. Prolonged exposure to low gravity could weaken bones, atrophy muscles, and even alter brain function. Radiation exposure increases cancer risks. And then there's the psychological toll, being millions of miles from home, trapped in a barren wasteland with no quick way back. But here's the twist: we might not have a choice. With Earth's climate in crisis, asteroid threats looming, and overpopulation straining resources, Mars isn't just a dream, it's an insurance policy. SpaceX's Starship, designed to carry 100 settlers at a time, could launch the first crewed mission as early as 2029. China's space agency plans its own Martian outpost by the 2030s. The race is on. And what if we're not alone? The ExoMars Rosalind Franklin rover, launching in 2028, will drill deeper than ever before, searching for microbial life. If it finds even a single fossil, or worse, something still alive, it will force us to confront an ethical dilemma. Do we have the right to colonize a world that already harbors life? One thing is certain: Mars is no longer a distant red dot in the sky. It's our next frontier. Every discovery, every experiment, every risk we take brings us closer to the day when boots crunch into Martian soil, not as visitors but as pioneers. The question isn't, can we make Mars habitable? It's, will we survive long enough to see it happen? The answer lies in the stars, and in 2025, we're closer than ever to reaching them. What's your take? Would you volunteer for a one-way ticket to Mars? Drop your thoughts below and brace yourself, because the future is coming faster than you think. The dream of stepping onto Martian soil is no longer confined to the pages of science fiction novels. As we stand in 2025, revolutionary breakthroughs are shattering every preconceived notion we had about the red planet. The latest data streaming back from our robotic explorers paints a picture that's both exhilarating and terrifying. Mars isn't just a dead rock, but a world teeming with possibilities and dangers we're only beginning to comprehend. Recent spectroscopic analysis has uncovered something that sent shockwaves through the scientific community: vast deposits of nitrates in Martian soil. These nitrogen compounds, essential for plant growth and DNA formation, suggest that with the right technology, we could potentially fertilize Martian regolith to grow crops. The implications are staggering. We may not need to transport all our food from Earth, but could establish sustainable greenhouse agriculture on Mars itself. Imagine vast domes filled with wheat, potatoes, and other crops under the pink Martian sky, their roots fed by carefully processed local soil. But the real bombshell came from China's Zhurong rover, which detected startling electromagnetic anomalies beneath Utopia planitia. Some researchers speculate these could indicate massive underground reservoirs of super salty liquid water, kept from freezing by geothermal heat and the pressure of overlying rock. If confirmed, these could be the largest bodies of liquid water ever found beyond Earth, potential oases that might harbor extremophile microbial life. The very thought that we might be on the verge of discovering alien life in our cosmic backyard is enough to make scientists lose sleep. NASA's groundbreaking nuclear thermal propulsion (NTP) program is changing the game for human missions. These advanced engines could slash travel time to Mars from 9 months to just 4, dramatically reducing astronauts' exposure to deadly cosmic radiation. The first prototype tests in 2024 exceeded all expectations, with some engineers whispering about potential 3-month transit times in the near future. This isn't just incremental progress, it's a quantum leap that makes regular Mars missions suddenly feasible. Perhaps most controversially, private companies are already staking claims on Martian real estate. While international treaties prohibit national appropriation of celestial bodies, loopholes allow for commercial exploitation. Several corporations have announced plans for mining operations targeting Mars-rich deposits of rare earth metals and deuterium, a potential fuel for fusion reactors. The ethical and legal battles over who owns Mars resources may well define the next decade of space exploration. The psychological challenges of Martian settlement are coming into sharp focus. Isolation studies in Antarctic bases and underwater habitats have revealed disturbing trends. Even carefully screened individuals can develop severe depression, paranoia, and cognitive decline in extreme environments. The first Martian colonists won't just need engineers and scientists, but expert psychologists, conflict mediators, and possibly even morale officers to maintain group cohesion when Earth is just a pale blue dot in the sky. As we push forward, the most profound question isn't technological, but philosophical. What kind of society will we build on Mars? Freed from Earth's political and cultural constraints, Martian settlers will have the unprecedented opportunity to redesign social structures from scratch. Some visionaries talk of direct digital democracy, post-scarcity economies, or even radical new forms of governance optimized for survival in an alien environment. The Red Planet might become humanity's greatest social experiment since the dawn of civilization. Every new discovery, every technological breakthrough brings us closer to that pivotal moment when humans take their first real steps toward becoming a multiplanetary species. The challenges are immense, the risks terrifying, but the potential rewards, the chance to ensure humanity's survival and evolve into something greater, makes this the most important endeavor our species has ever undertaken. Mars 2025 isn't just about science, it's about our destiny. The Martian frontier is revealing secrets faster than we can process them. In a stunning 2025 breakthrough, the European Space Agency's Mars Express orbiter detected mysterious methane plumes emerging from Valles Marineris, the largest canyon in the solar system. What makes this discovery earth-shaking isn't just the presence of methane, but its irregular, almost seasonal pattern that defies simple geological explanations. On Earth, 95% of atmospheric methane comes from biological sources. Could we be seeing the breath of Martian microbes? The scientific community is divided, but the possibility has ignited a firestorm of debate about planetary protection protocols and how aggressively we should search for life before human contamination becomes inevitable. Meanwhile, in a high-security lab at JPL, astrobiologists are conducting radical experiments with simulated Martian conditions. Their latest findings show that certain Earth extremophils, particularly black fungi and tardigrades, not only survive, but thrive in Mars-like environments when given minimal protection. Even more astonishing, these organisms appear to actively modify their surroundings, slowly breaking down perchlorates and releasing trapped oxygen. This suggests that genetically engineered, terraforming microbes could be deployed decades before human arrival to begin preconditioning the Martian environment. The ethical implications are staggering. We may soon face the decision of whether to deliberately seed another world with Earth life. The commercial space race has taken a dramatic turn, with SpaceX's recent announcement of Red Dragon, a modified, crewed Starship variant designed specifically for Mars landing and surface operations. Leaked specs suggest it will include an integrated hydroponics bay, radiation-shielded living quarters, and most intriguingly, a prototype ISRU, in situ resource utilization, system capable of producing methane fuel and oxygen from the Martian atmosphere. Elon Musk claims this technology could reduce supply needs from Earth by 80%, potentially enabling permanent settlements within a single decade. Competing ventures like Blue Origin's Blue Mars initiative are racing to develop competing technologies, setting the stage for a corporate space race that could accelerate Martian colonization beyond all official timelines. Perhaps most unexpectedly, Mars is teaching us shocking new truths about our own planet. Analysis of Martian core samples has revealed that the planet's magnetic field didn't just fade away. It collapsed in sudden, catastrophic events that stripped the atmosphere over mere thousands of years. This discovery has sent climatologists scrambling to re-examine Earth's own magnetic field fluctuations. The terrifying realization: our planet's protective magnetic shield has weakened by nearly 10% in the last 200 years, a rate of decline that matches what we've reconstructed from Mars's geological record. While Earth isn't in imminent danger, this revelation has added new urgency to both Mars colonization and Earth's climate crisis. The psychological profile of future Martians is being rewritten daily. Recent studies at the HIC's Mars simulation habitat revealed an unexpected phenomenon. Subjects exposed to prolonged Mars gravity simulations, about 38% of Earth's, showed remarkable neural plasticity, with some developing enhanced spatial reasoning and problem-solving skills. This suggests that Martian-born humans might evolve cognitively different from Earthlings within just a few generations. The implications for education, workforce development, and even basic human rights in a future Martian society are profound. Will Mars create a new branch of humanity? Some evolutionary biologists believe we may be witnessing the first steps in human speciation. As 2025 unfolds, every new discovery makes one truth increasingly clear: Mars isn't just a destination. It's a mirror reflecting our past, our potential, and our precarious position in the cosmos. The decisions we make in these coming years about technology, ethics, and exploration will echo through centuries of human history. The Red Planet beckons not just with resources and scientific wonders, but with something far more precious: a second chance for humanity to get things right. The countdown to our Martian future has already begun. The only question is whether we're ready for what comes next. The race to crack Mars' greatest mysteries has entered uncharted territory. In a development that sounds straight out of science fiction, NASA's Perseverance rover recently captured eerie nighttime glow emanating from within Jezero crater. The phenomenon, detected by the rover's ultra-sensitive UV spectrometer, appears to be caused by chemical reactions between subsurface minerals and lingering atmospheric oxidants. Some astrobiologists speculate this could represent an entirely new form of non-biological geochemical metabolism, a potential precursor to life that might still be active in Mars' depths. The discovery has forced a complete rethink of how we define habitable environments, suggesting that Mars may harbor strange, alternative biochemistries completely unlike anything on Earth. Meanwhile, the first prototype of SpaceX's Martian greenhouse has produced shocking results in simulated conditions. Their Red House system, combining advanced aeroponics with genetically modified crops, achieved full crop cycles using 98% recycled water and minimal artificial light. But the real breakthrough came when scientists introduced Martian soil simulant. Within weeks, symbiotic fungi had transformed the toxic regolith into fertile ground, capable of supporting Earth plants. This means future colonists might grow food in actual Martian dirt far sooner than anticipated. The implications are revolutionary. What was once considered a barren wasteland may become farmland within our lifetime. Underground radar scans have revealed another game-changing discovery: vast networks of interconnected lava tubes stretching for hundreds of kilometers beneath Mars' surface. These natural tunnels, some large enough to contain entire cities, maintain a near-constant temperature of -20 degrees Celsius, -4 degrees Fahrenheit, positively balmy by Martian standards. More astonishingly, ESA's Mars' radar detected what appear to be ice deposits lining many of these tubes, potentially providing both water and radiation shielding. Architects are already drafting designs for subsurface colonies that could house thousands in relative comfort, complete with artificial sunlight channels and vertical farming towers. The medical frontier is equally groundbreaking. Researchers at the Swiss Federal Institute of Technology have developed a revolutionary nanotech radiation sponge that can be injected into the bloodstream, capturing and neutralizing cosmic rays before they damage cells. Early trials show it reduces radiation-induced DNA damage by up to 80%, potentially solving one of the greatest health risks for Martian settlers. Combined with new gene therapies that strengthen bone density in low gravity, we may soon have the tools to make long-term Martian habitation medically viable. Perhaps most unexpectedly, Mars is rewriting the rules of planetary science. Analysis of recent meteor impacts has detected seismic waves moving through Mars' mantle at speeds that defy all predictions. The shocking conclusion? Mars's interior may contain vast reservoirs of supercritical water, not ice, not vapor, but water in an exotic fourth state that exists under extreme pressure and temperature. If confirmed, this could mean Mars has more liquid water than all Earth's oceans combined, locked deep within its crust. The discovery has ignited fierce debate about whether these hidden oceans could harbor life completely isolated from the surface for billions of years. As private companies race to launch the first crewed missions, a new geopolitical dimension has emerged. The United Nations Office for Outer Space Affairs is frantically drafting the Mars Accords, a framework to prevent corporate land grabs and ensure equitable access to Martian resources. Meanwhile, China's space program has quietly registered over 24 mining claims near the Martian equator, where orbital surveys suggest rich deposits of rare Earth elements. The stage is being set for a new kind of gold rush, one that will play out across interplanetary space. The most profound realization dawning on scientists in 2025 is this: Mars isn't dead, it's dormant. Every new discovery suggests a world that still ticks with geological and possibly even biological activity. The question is no longer whether we can survive on Mars, but what kind of civilization we'll build there, and what ancient Martian secrets might rise up to meet us. One thing is certain: the red planet will change us as much as we change it. The human future on Mars is no longer a question of if, but how soon. And every passing day brings revelations that accelerate that timeline in ways no one could have predicted just a few years ago. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Don't forget to check out our playlist for more incredible space content. Until next time, keep looking up.